Welcome to CS 179 Networking 1, Module 4. And this module we're going to talk about Chapter 7's TCP/IP Basics. And more specifically, we're going to get into the TCP/IP model, the application layer, the transport layer, the network layer, and some IP addressing. So let's talk about the application layer. The application layer, of course, is where applications such as email, websites, word processing, this is where they all run. And the application architecture is responsible for the way in which the functions of the application layer software are spread among the clients and servers on the network. So the functions are data storage, storing of data generated by programs, access logic, which is the processing required to access the stored data, the application logic, which is the business logic such as word processors and spreadsheets, and the presentation logic, such as the presentation of info to user and acceptance of user commands. So all these different things are part of the application layer. And they're made up of two different types of computers. You have both clients and servers. And clients can come in lots of different forms. You've got the personal computer, of course, that's the traditional client. You've got a terminal, which is really traditional. That's back from, say, the 60s and 70s, but there are still some terminals out there. You've got the network computer, which can be a personal computer that is networked, of course. You've got the transactional terminal, maybe like in a point of sale system, and you could have a handheld, such as a tablet or smartphone. On the server side, you could have a mainframe, which is what those terminals usually connect to. You could have, of course, a personal computer, could be used as a server. A cluster, where multiple computers are joined together to act as one device, used in high availability situations. Or a virtual server. So it doesn't run in a physical server, it runs virtually in, say, Hyper-V or VMware, that kind of thing. So there's a three different tier architecture. Of course, you've got the client. The client needs to connect to some place that has the application. You could have the application server, which could be a PC. That would be the application logic that we talked about just a few minutes ago. And you've got the application server, which would be the data access logic or data storage. And that could be the PC, a mini computer, or a mainframe. So some examples would be the World Wide Web, of course, or your web browser, email, file transfers using File Transfer Protocol or FTP, video conferencing, or instant messaging. Let's move down the list here from application to the transport layer, the second layer from the top, but we actually call it layer 6 because we start at layer 1 at the bottom at the physical layer. It is responsible for end-to-end delivery of messages, sets up the virtual circuits when needed. It is responsible for segmentation and reassembly. So what it does is it takes the packets and it breaks them up into smaller ones, smaller pieces at the sending end, so that way it can be reconstructed at the other side. So the reason for that is because a lot of times the data you're trying to send is larger than the message transfer unit size, which is typically at 1500. So if you're sending off, say, a 3000 sized message, and your MTU is only set to 1500, which it is by default, because that's the most efficient size, then you're going to have to split that up into two pieces. Well, the transport layer does that, and it does that using something called disassembly and reassembly, and that is a quiz alert. You will see that. All right, we talked in previous modules about TCP. It's a connection-oriented protocol, but now we're going to talk about UDP, which is a User Datagram Protocol. It's a protocol used for connection-less routing in TCP/IP, so it's UDP over IP instead of TCP over IP. It uses no acknowledgments, no ACKs, no flow control. It just sends the data as fast as it can, and if it doesn't get there, oh well, it didn't get there. But it's used in types of applications that aren't going to be as important as, say, things that need to have that connection, orientation, such as the ability to transact a credit card type of Amazon.com type of transaction that you might want to order something. That should really be controlled by TCP. But things that don't require TCP, such as you will use UDP, are things like games, DNS, DHCP, routing information protocol, SNMP, those kinds of things. All right, let's move on down to our third layer called the network layer. It's responsible for addressing and routing messages. Selects the best path from computer to computer until the message reaches its destination. So if you have multiple different networks and you have multiple different ways of getting there, the network layer is going to help find out the fastest and most efficient and reliable way to get there. Performs encapsulation on sending end. So it wraps up all those data packets into a nice package we call encapsulation. It adds the network layer headers to the message segments and performs decapsulation on the receiving end. Removes the network layer header at the receiving end and passes them up to the transport layer. And of course, a router, is the main device that's going to be running at the network layer. So network layer functions continued addressing. So each device on the path between the source and destination must have an address, such as an IP address. Assignment of addresses, translation between network layer addresses and other addresses are also part of the network layer functions. Routing, which is the process of deciding what path a packet must take, as we mentioned earlier. And there's two different versions that we have, two different IP versions. There's IP version 4 and IP version 6. Most of the time we're using IP version 4, but a lot of IP addresses out on the internet are using IP6 because we've run out of IP4 addresses. Now internally you can use internal IP addressing, such as the 192.168 network, the 172.16 through 31 network, and the 10.0 network. Those can all be routed internally, and we'll never really run out of those because every individual office and home can all use those same ones over and over because they're not routed out onto the internet. But on the internet, we only had 4 billion addresses because it was a 32-bit addressing scheme on version 4. We thought we'd never need more than 4 billion addresses. And of course, the scientists that created it were not correct in that assumption. So they came out with the IP version 6, which is 128-bit addressing. And basically, that's going to be billions and billions of addresses for every person in the world. So we should not have any excuse to run out of those anytime soon. So both versions have a variable length data field. Maximum size depends on the data link layer protocol. Ethernet's maximum message size is 1492 bytes. So when you get to the maximum size, adding all the headers and things like that in, it comes out to be 1444 bytes. But the typical size by default is 1500. So you've got the IP version 4 header, and you've got the IP version 6 header. And here's all the different things that get added on to those different packets. Now, you do not have to memorize this, so don't worry about it. This is just for informational only. So, to summarize, we talked about the TCP/IP model, the application, the transport layer, the internet or network layer, and we talked a little bit about IP addressing between IP version 4 and 6. So, thanks again for joining.